Welcome to chemistry classes by Vijay Kumar Sethi, class 12th chemistry. We will start new chapter alcohols, phenols and ethers, and in this video we will discuss about classification of alcohols, phenols and ethers. First of all, what are alcohols, phenols and ethers? The replacement of hydrogen atom or atoms in an aliphatic hydrocarbon by OH group results in the formation of alcohols. RH representing aliphatic hydrocarbon. This H is replaced by OH, we will get ROH. For example, from CH4, if hydrogen atom is replaced by OH, we will get CH3OH. The replacement of hydrogen atom or atoms in an aromatic hydrocarbon by OH group results in the formation of phenols. ARH. This is aromatic hydrocarbon. That is, this is aryl group attached with the H. This H is replaced by OH, we will get AROH. For example, from benzene C6H6. If hydrogen atom is replaced by OH, we will get C6H5OH. The replacement of hydrogen atom of a hydrocarbon by an alkoxy or aryloxy group. That is, alkoxy is RO and aryloxy, that is ARO, results in the formation of ethers. Like this is hydrocarbon. If this H is replaced by this RO, we will get ROR. Okay, this is the example CH3OCH3. Again, this is hydrocarbon. This H is replaced by ARO, OAR. We will get ROAR. This is the example CH3OC6H5. Okay. Classification of alcohols and phenols. Alcohols and phenols may be classified as mono, di, tri or polyhydric compounds depending on whether they contain 1, 2, 3 or many hydroxyl groups respectively. For example, one OH group is there, monohydric alcohol. Two OH groups are there, dihydric alcohol. 3 OH groups are there. This is trihydric alcohol. In the same way, in case of phenols, if one OH is present to the aromatic ring, this is monohydric phenol. 2 OH dihydric phenol. 3 OH trihydric phenols. Okay. Classification of monohydric alcohols. Monohydric alcohols are further classified according to the hybridization of carbon atom to which the hydroxyl group is attached. First category is compounds containing sp3 carbon OH bond. It means OH is bonded to that carbon which is sp3 hybrid. And this type of compounds again categorized in 3 subcategories. First one is alkyl alcohols. In this, OH group is attached to an sp3 hybridized carbon atom of an alkyl group, and they are further classified as primary, secondary and tertiary alcohol. For example, this carbon is primary carbon. Okay, and this carbon is also sp3 hybrid and OH is attached to this one. That's why this is primary alcohol. Now this carbon is a secondary carbon and sp3 hybrid. Okay, how this is secondary? If these two free valency of this carbon are satisfied by the another alkyl groups or another carbon, then this is a secondary carbon. That's why this is a secondary alcohol. Now this carbon is again sp3 hybrid and tertiary. That's why this is tertiary alkyl alcohol. Okay. Now second subcategory in this, allylic alcohols. In these alcohols, the OH group is attached to sp3 hybridized carbon adjacent to the carbon-carbon double bond, that is to an allylic carbon. And again they are further classified as primary, secondary and tertiary alcohols. For example, now see, these are two double bonded carbon atom and next to these, this one is sp3 carbon. Okay, and OH is group is attached to this one. Again further, this carbon is also primary carbon. That's why this is primary allylic alcohol. Okay. Now again in this case, this carbon is sp3 carbon which is next to this double bonded carbon atom, and this is a secondary carbon. That's why this is secondary allylic alcohol. Now this one is, this carbon is sp3 and this sp3 carbon is tertiary carbon and next to double bonded carbon atom. That's why this is tertiary allylic alcohol. Okay. Now third subcategory in this class, benzylic alcohols. In these alcohols, the OH group is attached to a sp3 hybridized carbon atom next to an aromatic ring, and again further classified as primary, secondary and tertiary. For example, this is aromatic ring, next to it this is sp3 carbon and this OH is attached to this one, and this carbon is again primary. That's why this is primary benzylic alcohol. Okay. Now this carbon next to this aromatic ring and this is a secondary. That's why this is secondary benzylic alcohol. This carbon is tertiary carbon, sp3 carbon and next to this benzene ring. That's why this is tertiary benzylic alcohol. Okay. Now next one is compounds containing sp2 carbon OH bond. It means OH is bonded to sp2 hybrid carbon atom. And again two subcategories are there. Vinylic alcohol, OH group bonded to a carbon-carbon double bond. Okay. OH group bonded to a carbon-carbon double bond, that is to a vinylic carbon. Now see, these are the double bonded carbon atom and this carbon is sp2 hybridized and this is also the sp2 hybridized. That's why this OH is attached to one of them. Then this is vinylic alcohol. Now next one is aryl alcohols or phenols. OH group bonded to sp2 hybridized carbon atom of an aromatic ring. As we know, in benzene each carbon atom is sp2 hybrid. That's why if OH is attached to directly this sp2 hybrid carbon of benzene ring, this is aryl alcohol or phenols. One OH is there, this is monohydric phenol. Again this is one OH monohydric, two OH dihydric, three OH trihydric. Okay. Classification of ethers. Ethers are classified as simple or symmetrical ether. If the alkyl or aryl groups attached to the oxygen atom are the same. For example, diethyl ether. This is the oxygen and to this oxygen, this is ethyl group and this is also ethyl group. Same alkyl groups are there. That's why this is simple or symmetrical ether. Mixed or unsymmetrical ether. If the two groups attached to the oxygen atom are different. Now this is oxygen and this oxygen atom is attached with, this is ethyl, this is methyl. Different. That's why this is unsymmetrical or mixed ether. Now in this case, this oxygen, this is C2H5 and this is C6H5. Both are different groups. This is again unsymmetrical ether. Now one question is there. Classify the following as primary, secondary and tertiary alcohol. Okay. Now I think you are familiar and you can identify carbon to which OH group is attached. If that carbon is primary, this is a primary alcohol. If that carbon is secondary, this is a secondary alcohol. If that carbon is tertiary, that is a tertiary alcohol. Now try to find out this OH group attached to this one. Okay, and this carbon is a primary carbon. How? Because this carbon is attached to only one another carbon. That's why this is a primary carbon. That's why this alcohol is a primary alcohol. Now in this case, this carbon to which OH is attached. Now this carbon is attached to this one. That's why this is also primary carbon and alcohol is also primary. Now this OH is attached to, again this is primary carbon. That's why alcohol is also primary. Now in this case, this OH is attached to this carbon, and this carbon is attached with the two another carbon, this one and this one. That's why this carbon is secondary, and OH is attached to the secondary carbon. That's why this is secondary alcohol. Now in this case, this OH is attached to this carbon, and this carbon is attached with this one and this one. That's why we can say this is secondary carbon, and hence alcohol is also secondary alcohol. Now this carbon attached with this OH. Now try to find out this carbon is attached with this is 1, 2 and 3 another carbon. That's why this is tertiary carbon and alcohol is tertiary. Okay. Now identify allylic alcohols in the above examples. Now allylic means we can say that is as OH group attached to the sp3 carbon atom, and that sp3 carbon atom is next to double bonded carbon atom. Is it clear? So first of all you find out double bonded carbon atoms. Now in first one, no double bonded carbon atoms are there. Now in second one, these are the two double bonded carbon atoms, and next to these atoms this is sp3 carbon and OH is attached to this. That's why this is allylic. Okay. Now in this case, no double bonded carbon atoms are there. In this case, no double bonded carbon atoms are there. Okay. Now this is benzene ring contains the double bonded carbon atom, but this is not regarded as a allylic part. Okay. Now in this case again, OH group is attached to this one, but this is not attached to the double bonded carbon atom. Now in this case, this OH is attached to this carbon, and this carbon is attached to these double bonded carbon atom. That's why this is a allylic alcohol. That's why our answer is second and sixth. Okay student, thank you. Subscribe my channel to get the new videos from this chapter.